We're back for more. So again, Bio 245, I'm Vanessa, and we're gonna go over bone tissue. So you'll notice on your term sheet, if you look under the tissues for week 2, that underneath bone, it has a bunch of little structures that it goes through. So we're just gonna go through those structures right quick. There's not too many of them, but the words are weird, so I'll lead you through how I would memorize them if I could. The first really confusing word is osteon, okay? A lot of people get really confused about osteons. But there's some great pictures in your book or on the internet that if you look, you'll see like the bone as a whole, like they'll do a little cross section and they'll look at the compact bone and then you'll see that it's made up of all these little ring-like structures, just like you saw under the microscope when we looked at bone tissue, right? They look like those little tree trunks. So each of those little individual tree trunks, so like here's an individual tree trunk, for example, is an osteon. So the osteon is the functional unit of bone. So it's not an individual cell, it's not any of that kind of stuff, it's just a functional unit of bone. And whenever you have this concentric shape going on, then you know that we have a strong structure here. Useful when we're talking about bones which support our entire body, right? So this is a model of an osteon, period. The thing making up the osteon, these little rings, these tree trunk rings, these are referred to as lamellae, so L-A-M-E-L-L-A-E, lamellae. And these are just rings of a calcium compound, and they are what makes up the solid tissue of bone, okay? Within these rings, you'll notice that over here we have these crazy looking eyeball guys that are red and blue, and then we have these little pocks, like these pock marks, right, that they kind of live in, okay? So these guys here, they're red and blue, are the actual bone cells. They're called osteocytes. So whenever you hear osteo, you should immediately think of bone and bone tissue, like osteoporosis, right? Osteoporosis is a weakening of the bones. The bone itself becomes porous. So osteo always means bone. Osteo, bone, site, cell. There you go, okay? Now, there are little crevices that they live in, and they also have a name. So these little crevices are referred to as lacuna, so L-A-C-U-N-A-E, lacuna. And I always say that the cell lives in a lake, right? The osteocytes live in a little lake, and that lake is just referred to as a lacuna. And the reason why I think about lake and lacuna is that actually lacuna means lake, okay? So I always think lac, lake, and that helps me. Okay, moving on. So you'll notice that these soft, delicate little cells suspended in this solid, hard matrix, they can reach their little arms across the lamellae like so. And you'll notice that where it's empty and there's no cell living there, that there's still these little channels, okay? The channels are called canaliculi, canaliculi. So the word canal and then iculi basically stuck on the end. So the way I always remember this is if you think about the life of this particular kind of cell, it can't move around, it's stuck in this one place. And it's in a solid matrix. Like, you know how bone is, it's hard. They can't move around and they're stuck in a solid matrix. So in order for them to get nutrients, they reach through these little canaliculi to get nutrients from this thing here called the central canal, which we'll talk about in a second. So I always think it's like reaching out little canals, it's reaching its arms out through these little canals to lick nutrients from the center. So canaliculi, that's what I always think. And like I said, it's getting stuff from the central canal. And in the central canal, we have these arteries and veins and sensory stuff and some lymph as well. But that's just like the center of each osteon, you're going to find one of these. So yes, bone is vascular. What did you know? And I believe I have covered all the terms, but one more thing I want to show you just real quick is here is just a side view of those cells, just so that you can see that yes, it is indeed an entire cell. That's it.